Good evening, sir. Hello. Good evening, sir.
Very good evening. How are you, Sankar?
Fine, sir. Let's go. I was the first.
Yeah, good
Good
evening,
evening, sir.
Congo. Very good evening, Nitish.
Yes, sir.
Good evening, sir.
Very good evening. How are you all?
Yes,
Fine,
sir.
sir.
I'm fine, sir.
That's great. So I hope that you remember where we have actually reached.
Yes, sir. We're doing art forms.
Yes, sir.
So one
So
second.
what? So what we have discussed it?
Second,
So
sir.
they did tell the protons. No, one second. I'll go take my book.
Okay, sure.
So we stopped at Rutherford's model of atoms.
Exactly. We had discussed the atomic number and the mass number, right?
Yes, sir.
So then we had to see a little bit regarding the isotopes, isobars, isotones. We discussed these.
We didn't discuss it, sir.
Okay, so we have to discuss these today. So tell me, is this board screen visible to all of you?
Yeah. Yes, sir.
Okay, so let's start then. Uh, let's see first of all, what are these isotopes? So can you define what are isotopes?
The same atomic number but different mass number. Or is it
Exactly.
the
They have same atomic number and different mass number. So we can say just like this that isotopes are atoms of same element. They are atoms of same element having different mass number. So if we are having atoms of same element but they have different mass number, so we just call them as isotopes. For example, if we just talk of the hydrogen, so in case of hydrogen, we know that we are having three well-known isotopes. One is known as protium. Protium is one of the isotope of hydrogen which has atomic number 1, but the mass number is also 1.
Yes.
This
Yes,
is all.
sorry, sir, but
And
I
then this.
wasn't there. Can you explain it again?
Okay, sure. Again, I
Sir,
am
we
just.
already studied this, no?
Have we studied
Not
this?
in the class.
Yes,
Not
sir.
in
We
Next
didn't
one's
start.
deuterium. Next one's
Yeah, we
deuterium.
studied
Next is
isotopes. We
tritium.
studied isotopes.
Okay, let's have a general look, then we will move ahead. Okay, protium, then we are having the deuterium. Okay,
Deuterium and tritium.
exactly. Then it is the tritium or tritium that is having actually the mass of 3, right?
Yes,
Yes,
sir.
sir.
Yes, sir.
So I
And
will
then we
write it
also studied isotopes of carbon
No, we
exactly that.
didn't.
and
Did we
nitrogen.
study isotopes of carbon?
Yeah, I think I
Yeah,
wasn't
and
there.
hydrogen.
Was I there?
No,
Okay. If we have just studied these, can you let me know that how many electrons, protons, and neutrons are in all these cases? So can you tell me in this protium, how many electrons are there?
One.
Okay, how many
One
protons?
electron.
so one
One.
in everything, sir.
One.
One proton.
No,
Okay.
0 neutrons.
Neutron
No,
is
I'm
not
saying
one.
one electron in everything and one proton in everything and zero
Exactly.
neutron,
Okay. Now
one
tell me,
neutron and two.
Eh.
That's what I
there will be
said,
zero
sir.
neutron. There will not be any neutron
Zero
in this
neutron.
protium. Exactly.
One
Here
One
it's not
neutron
neutron.
zero, sir.
in
Here it's
deuterium
one.
and two
That
neutrons.
is two.
Because we know that number of neutrons that is calculated A minus Z, right? Number of neutrons, it's always equal to A minus Z. Do you know what is A and what is Z?
Yes, sir. A
Yes,
is
sir.
mass number,
Atomic
Z
number
is
and mass number.
Z is the mass number. Okay. So if question is given to you that if we are having, let's say, He5, so can you tell me how many electron, proton, and neutron it has?
so 5 electron,
Five.
5 electron, 5 proton, neutron
No,
is
it's helium.
Oh, no,
Helium
wait.
is
No,
number is
2. It's
Sir,
2. So 2
electron is 2,
electrons.
proton is 2, neutron is 3.
exactly. Neutron will be 3. All right. So then let's move towards the isobars. So have we discussed isobars?
No, sir.
Okay, let's see on the next page. Shall I move to the next page?
Yes, sir.
Yes, sir.
Sir, we studied, sir. It is
No, we
atoms of
didn't.
different
we
elements
didn't.
that have
we
same.
didn't.
Then how did I write it in the notebook? Atoms of
Yes.
different elements can have same
Exactly.
atomic mass.
Exactly. So
Like
atoms of
Yeah, we did.
different elements.
like nitrogen
we
and
did.
carbon. We
Okay,
did
no
that.
problem. We'll
I
just
was
go through
there, I think, in that class.
having same mass number, right?
Yes, sir.
Yes,
Same
sir.
atomic number, sir.
No, they have different atomic number, but same mass number.
Oh, yeah.
For example, if I'm just talking of argon, atomic number is 18 and mass is 40. Let's say I'm having calcium, its atomic number is 20. Let's say mass is also 40. So these are your isobars. So can you tell me the number of electron, proton, and neutron in all these? In these?
10
Sir, electron
10
in calcium is 20, proton in calcium is 20, and neutron in calcium is 20. You can say the other one.
Okay. In calcium,
Okay.
there will be 20.
Yay. What? Okay, so it's 10 or 18, sir. Is that 10 or 18?
It is 18, not 10. It is in case of argon, we are having 18 electrons. Similarly,
But
protons will
neutrons
also
is
be 18.
20. In
Neutrons will
argon,
be
22.
No,
neutrons
20,
will be
da.
22.
22
here
and
it is
20.
Sir,
Da.
18. I thought it was 10, sir.
Bruh, sir told it was 18. Da.
I told it is 18.
Sorry, sir.
Okay. Now, can you tell me, for example, if I'm just writing, let's say this is my carbon 614 and nitrogen 714. What are these?
So
Are
they
they
are isobars with
Isotopes.
same.
They are
Isobars.
isobars.
Isobar.
Isotop. Oh, shit.
Isota. What is it?
Isotop.
They are also isobars. So can you tell me the number of electron, proton, and neutron in these two?
Sir, electron 6, proton 6, neutron is 8.
7, 8, 8, 8, 8, 8.
Bruh, the second I keep my headset aside and go to
Electron
take my
7,
book,
proton
this
7,
happens.
neutron
Sankalp, no
7.
one's listening.
You at least listened. That's why you responded.
Oh, that was a
No,
good
I
one.
didn't. I didn't.
So I hope it is now clear. So now can you tell me what are isotones then?
So,
Isotones
is
are
similar.
There's a crow
isotones. Oh
shout.
my god.
hey, sharp da. Tell something useful da.
So they are simply
Dad,
the
Dad, I'm
atoms
sorry.
of
He's not useful.
atoms of different elements, having same number of neutrons, having same number of
Neutrons.
neutron. So if you
Yeah,
have
that just
just
means everything is similar.
observed that in case of isotopes and isobars, number of neutrons were different. Just you can check it out here. It is 22 and here
See,
it's
if they
20, right?
same, the mass and atomic number will be same for
So
both the
here
elements, right, sir?
here atomic number will not be same, it will be different because they are atoms of
Yes.
different elements. They have same number of neutrons. This is very important.
So the mass number will
2,
be
4, and 18 and 20 will have the same number of neutrons. Ra.
For example, if I will just give the
Sir, if isotones means same number of neutrons in two elements, does that make them have same number of electrons and protons also?
no, they will
Hey,
have different
neutron
number
and
of
electron are
electrons.
equal, ada.
No,
Okay, I
right?
will write it here. So can you tell me what are these? Carbon
Sir, carbon
6.
and nitrogen.
Carbon and nitrogen.
Okay, nitrogen 7 and
we
14.
know
So
it.
can you tell me, are they isotopes or isobars, these two?
Sir,
No,
that's
sir,
The
they are
isotones.
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 Exactly, they are isotones. So can you tell me the number of neutrons in both these?
Sir,
wait.
in carbon 7 in 7 yes.
Oh, 7,
Yes.
7.
Exactly. So they have same number of neutrons. So definitely they are your isotones, right? Got it?
Sir.
Yes, sir.
But they will have different number of protons and electrons. So you will
Wait for
remember
the
that
7, 7 like that.
they have different number of protons and electrons. They have different number of electrons and protons. Got it?
Yes, sir.
Okay,
Sir.
so shall I move to the next page?
Yes,
Sir.
sir.
Yes, sir.
Okay, then tell me, if I will just tell you that will isotopes have same physical properties or different?
Different.
No, sir. They'll have different physical properties.
There are different physical properties.
And what about the chemical properties?
So they
That
have the
is,
same,
that is
sir,
also
but it is
different.
Same
No,
chemical.
that is same. They have same chemical
Same.
properties.
Yeah, that's what.
Okay, I will write it here. Why they
And
have same
different
chemical
physical
properties?
properties. So because they are
anybody
composed of the same atom.
They,
Same.
Because they have actually same number of electrons. Actually, chemical property is it is related with it is linked with the electrons. So they have same number of electrons. So definitely
Yes,
they will
sir.
have same chemical properties.
Oh,
This is very important. So I will write here that isotopes have same chemical properties but different physical properties.
So it's because the electrons are same, so they have
They
chemical
have
same.
same
That's what
chemical
he said, right?
properties. Exactly. They have same number of electrons, so definitely they will have same chemical properties.
Yes, sir.
Okay, this is to be noted down here. But different physical properties. Got it?
Yes, sir.
Yes, sir.
It's very important. You have to remember that isotopes have same chemical properties, but they will have different physical properties. Why they have same chemical properties? Because they actually
because of the
contain
same number of electrons.
Exactly. Okay, then let's move ahead. So can you tell me what are then isomers? Isomers.
Sir, why is everything in chemistry with ISO, sir? A lot of stuff.
Iso means okay. Iso means actually same. That's why.
Oh,
Iso means same, similar. So isomers means those compounds which have similar chemical formula, same chemical formula. I will write it here that compounds having
sir,
compounds having
same chemical formula means like first formula has 2 and 3 as valencies, and the next one also has 2 and 3 as valencies. Is it like that?
I don't know.
no.
No,
Okay,
no.
it's not.
I will tell you what is actually that. So compounds having same chemical formula but different properties.
So what is that name, sir?
Isomers.
Like
But the
PbO2 and ZnO2, are they isomers?
PB.
PbO2 and ZnO2.
First, tell me that does this exist as ZnO2?
Sir, ZnO2 exists.
Aluminate.
How it exists as zinc oxide is
Sorry,
like this. That is
ALO2.
ZnO.
Sorry, sir. Zeno.
Aluminate.
It doesn't.
ALO2. PbO2 and ALO2 are those isomers?
Aluminum oxide is like this. That is Al2O3. This is correct.
Sir,
What?
ALO2. Sir, in our book they gave ALO2, sir.
So you just now said what's given the textbook.
Dave, that's a radical. That's not a compound.
That's not the compound actually. See, AlO2. It is not actually a compound.
It's a
See,
radical.
if you just see here, aluminum is having how much valence? Can you tell me what is the valence of aluminum here?
3.
3 plus
3.
3. Sorry.
3 plus 3. Yeah.
3 da.
3, 10
Hello,
times.
sir.
Okay, again.
Hello, sir.
Hey, we are the most heroic battle ever.
I know that.
Okay.
Make a perfect duo. Hey, Pawan Kongul. So tomorrow we are playing Roblox fully. Okay.
Bro, you're thinking Kongwell as found. I've been asking Minecraft since the
Wait,
entire summer
sir, fine.
holidays there.
Can you hear me?
Yes, sir.
So,
Should I
Okay.
call Tarun? Tarun didn't join yet, sir.
I think he's so happy that he finally completed Tamil and is sleeping. What is isomers? Compounds having same chemical formula, right?
But different
sorry.
properties and structure, but different structure
Oh.
and properties.
Oh, yes, sir. So, but different structure on property.
So
And
can you
proper.
just share the screen? I'll just write that down.
Okay, sure.
Oh, Tarun didn't join it. Dude, I didn't see Tarun didn't join.
So is
My
now
mom is
screen visible
calling.
to all of you?
Yes, sir.
Yes, sir.
Okay, you just write that these isomers are just the compounds having same molecular formula but different properties and structure.
Yes, sir.
So for example, if I will just use one of the example.
Wait, I don't understand that example. It says there are no Al2O3.
No, that's not an example. He just
That is
told
not the
that
example, that was just
the
told by
correct
this.
form, the correct form of the compound.
I will just rub it out. It is not the example of this.
Unnecessary stuff. Sometimes I...
So have you noted down this?
Sir.
Okay. I hope that you have gone through the organic chemistry a little bit. Okay,
Sir,
if I
your
will just.
screen share. Your
Is
screen
it
share is
not
not
visible?
visible, sir. Yes, sir.
No, so you
But
stop screen sharing, sir.
Sir, I know the basics of organic chemistry, but not like very far into it.
Okay.
Compost is part of organic chemistry, right?
Day.
Is now screen
Organic,
visible?
it's different.
Is now
I
screen
don't know what.
visible?
See,
Yes, sir, I can
organic
see it, sir.
chemistry is basically all the compounds that are in nature. Am I right, sir?
That contain carbon and hydrogen mostly. Yeah.
Carbon and hydrogen.
So
So
if
I
I will
can
write
tell carbon dioxide.
carbon dioxide is not the organic compound.
Yeah, it has oxygen, right? Sir, so all
See,
isotopes,
Yeah,
all isotopes of carbon and hydrogen are organic
see now here.
compounds,
Okay.
organic
True.
elements.
Sir, methane, ethane, propane, butane, all of them are.
Exactly.
Organic.
So see,
Yes.
this is your butane, right? It contains
Yes,
4
sir,
carbon
butane.
atoms, is known as butane.
Sir,
Oh, I
Now,
thought
C4H10, right?
exactly. You can, in short, you can write it like this. That is C4H10, right?
H10.
Exactly. This is the chemical formula. What I was just telling you. This is the chemical
Oh.
form. C4H10.
Yes.
Now, if I will write like this, another one, that is CH3, CH, and here CH3, and then again here CH3. So, can you tell me what is the chemical formula of this one?
CH9.
So,
Sir, this is
same. I don't know. Same thing, sir.
Exactly, it is also C4H10, but there is difference. This is known
So
as
because
isobutane.
it's CH3 and then C2H4 and then CH3 if you
Now,
combine.
what is the difference? This is known as N-butane. This is known as isobutane. What is the difference between the two?
it's because one CH is having 3 bonds, but in other ones CH will have only 2 bonds.
No,
One
all
bond
the
actually.
carbon atoms have all the carbon atoms have formed the 4 bonds. Carbon always forms the 4 bonds.
So it's your screenshot stopped.
Is screen
Sir,
visible?
no, sir.
It stops,
No,
sir.
sir. It stopped.
But there is some problem then. Why it is stopping automatically?
Wait, there's something written there under.
So is it
Where?
now visible?
You.
Yes, sir, it's visible, sir.
Okay, now tell me that what is the difference between the two? Both have the same molecular formula. You can check that both have C4.
Isomers.
Exactly, they are your isomers. Both have same molecular formula, that is C4H10. Both have same
Different
molecular
structure. Structure is different.
structure. See this first one, that is N-butane. It has street structure, right? It has
Yes,
street.
sir.
Exactly. And next one is having the branched structure, right?
T
Yes, sir.
structure.
Yes,
T
street, and this
structure.
have the branched structure. So such compounds are known as isomers, which have same molecular formula, but they have different.
Sir, I have a doubt.
Okay, tell me.
Sir, now so we see when it is CH4, it is methane. When it is C2H6, it is ethane. When it is C3H8, it is propane, and C4HN, it's butane. So if we
Exactly.
keep on adding carbon and hydrogen, will we keep getting new elements, sir?
Exactly. We will keep getting new compounds. For example, this is
Okay.
methane, this is ethane, this is
Ethane,
propane. Exactly. This is butane. Next will
butane.
be the pentane.
Sir,
The
so
next.
there are infinite possibilities.
Exactly. That is why we are having
Again,
But we
large
haven't
number
discovered
of.
everything.
That is why we are having large number of organic compounds. We are having more than 9 billion organic compounds. It's
So it's
really
not
a huge
infinite.
number. That is why in organic chemistry, elements are only few, but compounds are so many. It is due to this isomerism, because of these isomers.
Yes, sir.
So this is very
I
important.
just hope we don't have to learn 9 billion compounds for 10.
Hey, talk something sensible now.
Okay. Then, so shall I move to the next page?
Yes.
yes.
Then we have to actually study the structure of various molecules.
Sir, is there a pattern on how the
Mhm.
carbon and hydrogen is being added to form new compounds?
Yeah, exactly. There are various rules, there are various reactions which you have to actually follow. For example, carbon in organic chemistry, it always should form the four bonds. This is one of the criteria, that it should always form the four bonds, because it's always tetracovalent. It forms the four covalent bonds. This is one of the important point. For example, if you just talk of aldehyde, let's say I'm having this as ethanol, which is also known as acetaldehyde. So here you can see that carbon has formed the four bonds. One is here, another is here, and two bonds are with the oxygen. So that is why it should form four bonds in all organic compounds. So this is one of the important criteria here.
Yes, sir.
This is its valency. Okay, next, now let's see. We have to actually first to see the two types of bonds. One is known as ionic bond, another is known as covalent bond. So have we
So
discussed
once
it?
can
What?
you go to the
Sir, but
previous page, sir?
carbon is
Once can you go to the
tetravalent,
previous
right,
page?
sir? It always forms a tetravalent bond, right, sir?
Yeah, exactly. It is always tetravalent. Okay, I will show the previous slide here.
I'm in the last.
So what are we going to learn next?
Yes.
What are we going to learn next, sir? What did you say?
I said that we will study now the two types of bonds. One is known as ionic bond and covalent bond. Have
Covalent.
you discussed? Have Have you any knowledge regarding the ionic and covalent bond?
Sir,
Yes,
ionic
sir.
bond is when the atom just gives away the electrons to the other atom, but covalent bond is when two atoms share the same electron.
Exactly. That means in case of ionic bond, there is complete transfer of electrons. I will write it here. So, so ionic bond, it is also known as electrovalent bond. You will note down this, that this is also known as electrovalent bond. So this ionic bond, it is formed by complete transfer of electrons. First, let's define this. What is ionic bond? It is nothing but the force of attraction between oppositively charged ions. Force of attraction between oppositively charged ions, right?
Yes, sir.
Oppositively means one should be the cation, another should be the anion, right?
Sir, so in one atom, there are more number of protons but less number of electrons. That atom is willing to take more electrons. So that atom, which has more protons, it will attract the electrons from the other atom and take it to itself.
Exactly. For I will give you the example. For example, so how it is formed? This ionic bond is formed by, I will write it here, that it is formed by complete transfer of electrons. It's formed by complete transfer of electrons. Complete. So have you
So
got
what
this?
is BLW?
It is between B slash W. It is between oppositively charged ions.
Yes, sir.
Between. Okay. So I am saying that It is formed by complete transfer of electrons. It's formed by complete transfer of electrons.
Yes.
For example, if I'm just talking of this sodium, so can you tell me what is the electronic configuration of sodium?
Sir, it is
So it is
Na1
2,
Oh,
4,
sorry.
8, and then 7. Oh no, one. Sorry, different.
Exactly, because there are 11 electrons. So in the
Yes.
first shell, it will be 2, then it
2,
will be
and
8,
then
then
8,
it will
and then 1. Yes.
So this is actually, it is according to the Bohr's model, Bohr's rule, right?
It's
For
the
example, if
nucleus in the middle, and then ring
exactly,
orbits.
orbits
then
are
it is
2
the
in the first
first
orbit,
orbit, that is
8
the
in the
K,
second orbit,
8 in the second
K,
orbit.
L, M, N.
L,
KL
exactly,
MN.
then M, then it is the N, and what after N?
Orbits.
I don't know.
It is O, then it is P. In the alphabetical order you have to go.
Oh,
N,
K,
O,
L, M,
P.
N, O, P, Q, R, S, T, U. What
Sir,
are the
Exactly.
why
A's?
do we not start from A?
Yeah, so that's what I asked. A, B, C, D. What happened to the A, B, C, D?
Yeah, it is actually given by the Neil Bohr that he started from the first, he called this first shell as K, and then L, and then M,
Sir,
then
like
N.
we are asking why did he do it that way?
Oh, ask him that.
It is actually these terms, they have actually come from the spectroscopy. That is actually you will study in the higher classes. Spectroscopy is one of the branch of chemistry which deals with the study of spectra. For example, if you just know that periodic table has been divided into 7 blocks: S block, P block, D block, and F block. These terms have also came from the spectroscopy. S stands for sharp, P stands for principal, D stands for diffuse. So you will study ahead in the higher classes that they have actually came from spectroscopy. So that's why he started from this key element.
Sir, A block,
Okay.
B block, C block means period 1, period 2, period 3. Is that one?
No, it is just block. S block, actually, these elements contain 2 groups. That is group first and second. P block, it contains 8 groups. D block, it contains the 10 group.
10. Okay.
It is just like that. Okay. You will study when you will actually study in detail the modern periodic table, then you will actually go through this. Here you have to only study that the name, that is KLMNOP, that is the name of the shell, and the number of electrons. So can you tell me how many electrons can be accommodated by this key?
2.
It is given
Sir, sir, only in the first one, 2,
2.
and from then on,
2,
8.
8, 8, 8, 8.
2, 8, and then what?
8, 8, 8, 8, 8, 8.
8,
Exactly.
8, 8, 8.
No. It is actually like this, that I will write it here.
Oh, yeah, 2, 8, 10.
Number of electrons in any shell,
But
in any orbit, it is given by the formula given by the Neil Bohr, that is 2n square.
2n square. 2n square.
and square.
And what is the value of
8,
n?
16,
Value-
32,
Can you tell me what is the value of n in case of this K shell
32.
orbit? N value is 1, and
Oh,
here n
1.
value is 2,
2,
2,
3, 4,
3,
5, right?
4, 5.
5.
Exactly. For O, it will be 5. Okay, now tell me, for example, if you are having K, so how many electrons you can
2.
accommodate? That is 2 into 1 square. 1 square is 1. 1 into 2, that
1
is
into
2.
2
2
is 2.
electrons. Okay, for L, how many electrons you can accommodate?
8. 4 into 2
Sir,
is
but,
8.
sir,
Exactly.
8.
in,
No, that's not how much it can accommodate. It's how much it can hold. It's a different
How
thing.
much it can accommodate? It is the maximum number of electrons that can be accommodated in any
2
shell.
into 3
Why?
square. 9 into 2, which is 16. See, 9 into 2, 18.
Okay, tell me if you are having any doubt, you can tell me.
32.
That means 32 electrons can be accommodated in the N shell. This is very important. I hope you will remember this. This is
And then
very
5
important.
O is 50.
So in M, there will be 18 electrons. In N, there will be maximum 32 electrons. And can you tell me in O, how many?
50. 50.
Exactly 50. Okay. So the electronic
Sir, I don't
configuration of
get it, sir. Like
why?
in example, when we take calcium, in the first
Exactly.
shell there will be 2, in the second shell there will be 8, third one also it will be 8. Why is there not 18, sir?
Very good, very good. This is very important question, and I will give you the answer. It is actually this electronic
Because the
configuration.
octet rule.
Yeah, exactly. One is the octet rule. Another is this electronic configuration. It is in terms of subshells. It is not in terms of shells. It is in terms of subshells. See, actually, whenever we are having any shell, then there are subshells in it. Then there are orbitals in it. It is just like if you are having any building that acts as a shell. Then there are floors. let's say ground floor, first floor, second floor, they are your subshells. Then there are the rooms in which we are actually living. Rooms are actually the orbitals. So same is here the case that these are the shells, then there are subshells inside it. So this is actually the subshell, and this is also following the octet rule. I hope you have studied the octet rule, right?
Yes,
Sir,
sir.
we did, but I forgot it.
Okay, no problem. We will study what is actually the octet rule. First to note down this. So the electronic configuration of sodium, it is 2, 8, 1, right?
Yes, sir.
Shall I move to the next page?
Sir, 1 second.
Yes,
sir.
sir.
1 second. Sir.
Okay.
Sir.
Okay, so let us see now what is actually the octet rule, why there is complete transfer of electrons, how this ionic bond is actually formed. So let's write what is actually the octet rule. So octet rule, it actually states that atoms combine in order to complete their octet. So I'll write it here that atoms
Oh,
combine.
it's when if it's 0, 4, or 8, it's stable. 1, 2, 3 will lose. I mean, gain. No,
Exactly,
lose.
atoms combine in order to complete their octet. In
4,
order to
5, no, 5, 6, 7, they will lose.
in order to complete their
Gain,
octet,
like that,
right?
sir.
Octet means that is 8 electrons in the valence shell. Octet means that is
It's
8
hydrogen or helium.
electrons in valence shell.
Unless it is hydrogen or helium, right, sir?
Exactly. In case of now we are having few elements which are not following the octet rule, they are following the duplet rule. Duplet rule, right?
But they are
Yes,
all
sir.
the isotopes of hydrogen and
Duplet rule, that means 2 electrons in the valence shell, 2 electrons in valence shell, outermost shell.
Like helium.
First write down this that duplet rule, it means 2 electrons should be there in valence shell. So now you have to remember that this duplet rule, it is followed only in few elements. So followed by, I will write it here, followed by hydrogen, similarly helium,
So anything 2 or less.
similarly lithium and beryllium. Only these 4 elements, they follow the duplet rule. This is very important. I hope you will note down this. This is
So
very
lithium
important.
has 1 in its final valence shell.
I will give you the
1.
example in detail. No, you
Oh,
have not to
yeah.
worry.
Okay. Now
When
I
it
get
has 1, it will have to give that 1.
So that means calcium is also a duplet rule, right? So because it ends
No, no,
in 1.
no. Calcium will follow the octet rule. I will tell you how. First, you just note down this. This is very important.
Yeah.
So, octet rule means atoms should have 8 electrons in their valence shell, and duplet rule means there should be 2 electrons in the valence shell. But this
2
duplet
or
rule,
less.
it is only followed by hydrogen, helium, lithium, and beryllium. This is very important. Okay, now I will give you the examples.
But
For
then we
example,
can just write it as duplet rule is followed only by hydrogen, helium, lithium, beryllium. Right, sir?
exactly, it's only followed by these elements. Okay, I will give you the example. For example, tell me how hydrogen actually exists. Hydrogen, it has only 1 electron, so it
Yeah.
combines with another hydrogen. So that means it is mutually
Another
sharing.
So the H2
Exactly,
or
exactly.
duplet.
Now
Sir,
you
so
can
it's
see
a covalent bond.
No,
exactly
it's
this
not.
is the covalent bond. This is the covalent bond because it is mutually formed by mutual sharing of electrons. So this is
This is a covalent bond.
exactly
Yeah.
this is a covalent bond. So that means, can you tell me hydrogen has completed its octet or duplet here?
Sir, octet.
Duplet. How octet?
Duplet,
There are
there's two in the
yeah,
valence shell.
there are only 2 electrons.
Oh, its first shell is
There's
the
two
valence.
did a covalent bond, and then now there's
Yeah,
two
Okay,
are
let
less
me
stable.
give you another example. For example, if I will just take fluorine,
Yeah.
can you tell me how many valence electrons are there in fluorine?
So the wait, it's
Right. It is
I remember.
flu-
So fluorine has atomic, not electron 9.
it has It has 9 atomic numbers, so that's
Sir,
2 comma
sir,
7.
two, sir.
Sir, this is no, no,
7.
this is not a duplicate rule. Sir, this is not duplicate rule.
Exactly. See here, fluorine has 7 valence electrons, correct? So now tell me that among these 7 valence electrons, what it will do? It will just share
Ions
one electron.
have so many lone pairs.
It will just share one electron with another fluorine. You can just
Then
draw
there will
it.
be like
Sir,
6
sir.
lone pairs. Each.
Sir, but
Yeah.
atomic number is 9 and mass number is 90.
It's
So
electron,
electrons.
ra,
Sorry, sir.
not neutron.
It is only the electron. Whenever you are giving the electronic configuration, it means the number of electrons. Okay, now tell me, is octet here complete or not?
No, sir.
Uh,
No,
Octet
no,
is
it's not.
complete.
It's not.
it's not.
It's not.
Octet is complete. You can check it
Sir,
out.
only
yeah,
when it
oh,
is
okay, okay.
shared, sir.
Oh,
Only
yeah,
when
when
it
it's
is
shared.
shared.
Okay. Okay.
Yeah, when they mutually share, then the octet of both the fluorine atoms it gets completed. So here
This
it
is
is the
not a
octet rule.
duplicate.
Here it is also the covalent bond formation here. So it follows the octet rule. I told that octet is followed by all elements except these
Yes.
4, right? And
Yes,
this is
sir.
following the duplet rule here.
Sir, so basically every single bonded covalent bond is duplet is followed by
Ex-
duplet rule.
You can say that every single covalent bond it contains 2 electrons, right?
Yes, sir.
So in
Okay, now
case
tell
of
me. Now tell me if I'm just writing, let's say I'm having a double bond. In case of oxygen, there is double bond.
yes, sir.
For example, okay, tell me how many valence
Cannot
electrons?
follow a
Sir,
duplet rule.
valence, yes, sir. Oxygen has
Sir, oxygen is eight, sir,
eight electrons. So we'll have
eight has
definitely
8
six.
It
electrons.
has 6 valence electrons, right?
Yes, sir.
Yes,
It'll have like 4 lone pairs, and then 2 will covalent, and 2 will
It
have
will
covalent.
just share 2 electrons
Two
mutually
covalent.
with another oxygen atom in order to form double covalent bond. There will be double bond formation. So
I
can you
don't
tell me is octet now complete or
Yes,
not?
sir.
Yes, sir.
Yes, sir, it's
Octet
complete,
is
sir.
complete.
Exactly. Octet is complete for both the oxygen atoms. So there is double covalent bond. This is very important. Double covalent bond, and it also follows the octet rule, right?
Yes, sir.
Just note down this. So here it was the single covalent bond. So can you give me the example of any molecule in which triple covalent bond is formed?
Sir, maybe phosphorus.
Nitrogen. Can you tell me how many elements are, how many
Sir,
electrons?
7, sir. 7.
Exactly 7. 7 is the atomic number. How many valence
5.
electrons it is?
5.
Exactly.
2, 5.
2,5.
5
Exactly.
the
2,
valence electron.
Yeah, that's what 5. That's what I said.
You said 2.
yeah, you also
2,
said the
5.
correct.
2, 5.
Now tell me among these 5 valence electrons, how many it is mutually sharing with another
3
nitrogen?
electrons.
3.
So that means it will form the triple
Triple
covalent.
covalent bond.
Triple covalent bond.
So can you tell me with this is octet complete for both or not?
Yes, sir.
Exactly. So you'll just note down this that in case of N2 molecule, that is the nitrogen gas, there is triple covalent bond and it also follows the octet rule. Triple covalent bond. So it also
Sir, will
follows.
we get this in learning room test?
Exactly. This is very, very important. You will get all these structures. You have to draw the structure of these molecules. So that's why I'm explaining this. This is very important. You should be able to write these structures. You should also be able to write the number of valence electrons. Similarly, which bond will be formed, ionic or covalent. That's very important. So all these examples which I have given here, they are the examples of covalent bond, right?
Sir.
H2, so there is covalent bond. Similarly, F2, there is also the covalent bond. O2, there is also the covalent bond. In case of N2, there is the mutual sharing, so there is also the covalent bond. So there is triple covalent bond, right?
Yes,
Okay.
sir. Sir,
So shall I move?
calcium. Okay, okay, nothing.
So
Okay,
one
I will
second, sir,
answer.
almost.
Yes, I will explain all these. Calcium, I will also explain. So first, let me know
Calcium
that
is ionic bond, right?
Exactly, calcium is a metal, so that will form the ionic bond. Metals form ionic
Oh,
bond.
so every non-metal forms a covalent bond.
Except hydrogen, helium, lithium, beryllium.
You see how you have to remember, if non-metal reacts with another non-metal, then there is definitely the covalent bond. But
Okay.
if non-metal reacts with a metal, then there will be ionic bond.
Sir, when a metal reacts with a metal,
I think
No, there will be metallic bond at that time. When metal reacts with metal, there will be metallic bond. This is another third type of bond. Okay, so shall I move to the next page?
no, one
Yes,
second, sir.
sir.
I'm in the last one. I'm in the last.
Okay, okay.
Sir, you forgot to draw 2 electrons in the nitrogen, sir.
No.
Yes,
No.
that did.
It
Sir,
has 5
you-
valence electrons,
you-
sir.
Oh, 5 valence electrons.
You have to only consider the valence electrons whenever you form the bond, any whether covalent bond or
Okay,
ionic.
okay, yes.
Yeah. You have nothing to do with these inner electrons. You have just take the valence electrons in the count, because we have to complete the octet. According to the octet rule, there should be 8 electrons in the valence shell. So we are just only talking of the valence shell. Valence
Yes,
means
sir.
outermost.
Done, sir.
Okay, so let me write in short that how you will remember. You will just remember that whenever there is metal and it reacts with the non-metal, you have to remember that there will be ionic bond, right? Then next you
Yes,
have to
sir.
remember that if you are having a non-metal and it reacts with another non-metal,
You get a covalent bond.
A covalent.
it will
Except
be
hydrogen, helium, lithium, beryllium.
Sir,
definitely
it will.
there will be covalent bond.
Yes.
Covalent hydrogen, helium, lithium, beryllium.
And
I
the
mean, they
third
also
one,
form a covalent bond. Like this.
Also
I will
form a
give you the
covalent.
example.
Sorry, I take back what I said.
I will give you the examples of all these. You have not to worry. So metal, when it reacts with another metal and there is the compound formed, so that will be metallic bond will be there. Metallic bond.
So, can you
So
express a metallic bond with the diagram? Is it like same?
I will tell you each and everything. For example, ionic bond is in case of NaCl, sodium chloride. There is sodium is the metal and chlorine is the non-metal, right?
Yes, sir.
And covalent bond, for example, if I am just talking of Cl2 molecule, Cl2. So in case of Cl2, both chlorine atoms are non-metal, so there is covalent bond. Now, if we just talk of metallic bond, for example, you take any metal like copper, you are taking the sodium, any metal, zinc, all these are metals. So metals have metallic bond. Now let's explain one by one each and everything. For example, if I'm just saying that I'm having a compound which contains lithium and hydrogen. So you have to tell me which bond is there and is it
It's a
following
covalent
octet rule or-
Covalent bond.
Covalent
Sir.
bond.
Covalent bond.
So okay, I will tell you that there will be ionic bond. Tell me how.
Sir,
Oh, lithium is the no, it's not. Okay.
Lithium is the metal. Lithium is the
Yeah.
metal.
Okay. Okay. I follow.
Hydrogen is a non-metal.
Lithium is
Simply.
a metal and hydrogen is a non-metal.
lithium is a metal.
Yes, lithium is a metal. Hydrogen is a non-metal.
Sir, I thought lithium was a gas, sir.
No.
Noble
Lithium
gas.
is non-metal.
No, I know it's not a noble gas, but I thought it was a gas like oxygen, nitrogen.
I know.
Okay,
I know you thought. Yes, sir.
Okay, yeah, there is very important point to be noted down. If you will just remember, there are only 11 gases in the whole periodic table. So will you remember? Then I will just draw here.
Yes.
Will you remember that which are the gases in the periodic table?
We will remember it, sir, but will you ask it in the exam?
Okay, I will tell you. Hydrogen exists as gas. So hydrogen element, it is the first. Helium also exists as gas. Okay. Next is
Carbon.
nitrogen
Beryllium.
exists as a gas. Oxygen exists as a gas.
So carbon.
Carbon is a
Carbon
solid.
is not a gas, sir. Carbon is a
not
metal.
gas.
Non-metal.
Carbon is a non-metal. Yeah.
Exactly, but that is not the case. That
Sir, are all noble gases
The fluorine is not.
all noble gases gases?
exactly. Fluorine is a gas. Chlorine is also a
Okay.
gas.
Chlorine
Neon
is
we
a
are
gas.
having a noble gas. Argon is a gas, noble gas. Similarly, krypton is a
Sir,
gas.
fluorine is a gas.
Yes, sir.
Yes, fluorine is
Sir,
gas.
why do these things
yes,
have
fluorine is
liquid names but they're gases, sir?
Chlorine came. That
It's
liquid
actually you
chlorine
have
came
to
from this
remember
name.
that which exists in the gaseous state at room temperature, that's your gas. So can you count these? How many I have noted down here, written down?
4, 5, 6, 7, 8, 9, 10, 11.
There should be only 11 gases in the
Yes,
whole
sir.
periodic table.
1, 2, 3, 4, 5, 6, 7.
I already counted.
Yes, sir, 11, sir.
Exactly. So you will remember there are only 11 gases among 118 in the whole periodic. And can you tell me how many how many elements exist in the liquid state?
First is
Only two.
Sir, something only
2.
two. Sir,
Only two.
what?
H2O.
Can you,
Oh, wait, no.
Hey, that's
can
a
you tell me?
compound.
Yeah, I know that.
You are not, I'm just talking of elements only, not the compounds. Elements. So mercury is the element. It exists
Oh,
in liquid state. And there is next bromine. Bromine also exists in the liquid state. These
so
are
I
only
thought
the
it.
two elements.
So I thought it was in a crystal state, sir.
No, they exist in
Bromine.
the liquid state. This is very important. You have to note down this. And all other elements, they exist in the solid state. Okay, I will write it here that all other elements exist in solid state.
Inequality,
All
sir.
other elements exist in solid state. So have you noted down this?
So what is that Kr in the gases?
Kr is the krypton. It is the noble gas, krypton. Xe, it is the xenon. Rn, it is the radon. Ar, it is the argon.
Oh yes, sir.
Okay.
Wait, I
So
think
what we got? We got
Xe is Xeon, right?
it is xenon. Xenon.
xenon, ra.
Xenon.
Rn is radon.
Exactly, it is the radon.
It's a radon, D or
And I
It is
think
D or
gas.
it's an N.
yeah, I
It's-
didn't say the last letter there.
It is Rn, radon. Okay, so now what we got? We got that lithium hydride. This is your
Why
lithium
does
hydride.
Mercury have that accent on top of it, sir?
Yes,
It's
what?
not
Mercury?
That an accent on top of the G.
accent. Oh, I think it's just a style of writing.
Yeah, it is just this.
Sir, I thought it had some sort of equivalent or a
Yo,
No. You can
I mean-
just write Mercury like this. That is H and G. It is just the way how you write. You can write G like this, or you can also
it's
write.
just a Latin name, so it does make sense.
No.
I know there was some speciality about Mercury.
No, there isn't any specialty. It is just the way I write it. Okay, now tell me this lithium hydride, is it now ionic bond or covalent?
Ionic.
Ionic.
Okay, now tell me the how it is actually formed. So lithium, its atomic number is 3, right? What is the electronic configuration?
So
It's 2,
it is
Sir, 2 and 1.
1.
2 and 1.
So it is an ionic. See, no, it's a ionic bond. It's an ionic bond.
See now here. Now in case of lithium, can you tell me is octet complete or duplet complete? No, neither octet nor duplet. And I have already told you that lithium will follow the duplet rule, right?
Oh,
Yes, sir.
yeah.
Okay, now
right?
tell
Yes,
okay,
sir.
now tell me how it will just complete its duplet. Okay, if
Sir,
we
it
just
will
talk
give, sir,
It
the
will do
lithium
a
will give one of
covalent
its,
bond.
the valence
We'll
shell
do a
to the
single
hydrogen to
covalent
make.
bond, sir.
see
No.
here.
It
See,
will-
No, sir, can I
It
say,
will do a
sir,
single
the
covalent
lithium,
bond.
no, sir,
Okay, tell me.
lithium will, hey, be quiet, sir, lithium, the last valence shell, 1, it will give it to the hydrogen, so that hydrogen will finish 2 in its
Wait, I
valence
didn't
shell and
see it was
lithium 2 in its valence
exactly,
shell,
exactly
so
right,
they
exactly right, exactly. So see, lithium will just lose one of its electron. When it will just lose this one electron, its duplet will get completed. It will have now only 2 electrons in its valence shell. and this same electron, it will be just taken by this hydrogen. When this hydrogen takes this electron, it will also complete its duplet. It will form H negative ion.
See
So
that
it has
hydrogen
the,
gas, sir.
yes.
How,
Now we are
how
having
are
the,
you saying covalent when sir just said ionic?
yes,
Yeah,
it is ionic.
I thought only lithium. I only thought lithium, like lithium alone.
Now tell me, it is now your Li positive and H negative. What are they? They are the positively charged ions. One is
Positively
your
charged.
cation, another is your anion. So I
So
told
now
what
next,
ionic bond. What is ionic bond? Can you remember what is ionic bond?
yes, sir.
Ionic bond is
bonds are
when one
activated.
positively
What a
charged
force of
ion attracts a negatively charged ion. Opposite ions attract.
Yes, I have told you
attraction
that
between
ionic
opposite
bond is the
ions.
force of
That's what I
attraction
said. L.
between the oppositively charged ions. So
Just
this is
giving
the force. So this
permission
is
to
your
it.
ionic bond. It is the force of attraction between two oppositively charged ions. So we are having cation and anion. So they are oppositively charged ions. So the attraction between them, that is nothing but the ionic bond, or what you also call it as electrovalent bond, right?
Yes, sir.
Yes, sir.
Sankar, I didn't want to
So,
make a baby cry. Yes, sir. You can
so
start.
shall I move to the next page?
Yes, sir. You can go, sir. I think Sankalp is writing.
No, I'm not.
That means you can go to the next page, sir.
Okay. Now, if I just write a compound that is MgO, and you have to tell me, will there be ionic bond or covalent bond?
Sir, I am covalent
Ionic bond. Ionic bond.
No, it's a
Hey,
covalent
Exactly,
bond.
there will be ionic
Ionic,
bond.
Ionic bond.
Mg is a
I keep
metal.
making the same mistake. Metal
Mg
and
is a
non-metal ionic.
metal.
Why do I not?
Magnesium is the metal, and oxygen is the non-metal.
Non-metal.
I keep not seeing the non-metal. I have a hatred for non-metals.
I know,
Now
right?
tell
Even
me
I
that
have to. I used to have that since 6th standard.
Hate
how,
of cap.
how ionic bond will be formed here. See, magnesium, it has 12 electrons, so its electronic configuration will be 2, 8, 2, right?
Sir.
That means its octet is not complete. Now, in order to complete its octet, it has to lose these 2 electrons, right?
Yes, sir.
Yes, sir.
Okay, I will write it here that magnesium loses 2 electron in order to form Mg2 positive, correct?
Yes, sir.
Yes, sir.
So when it is Mg2 positive, that means its electronic configuration will be 2, 8. So its octet is complete.
Yes, sir.
Now tell me that of oxygen.
Oxygen does a
Sir,
covalent.
oxygen has two
Oxygen
six,
has a double covalent
six,
bond,
two
so
six.
it has 6 in the end.
Now oxygen has 6 valence electrons, so
Hey,
its octet is
That's
also
a
not.
That is. Hey,
Yeah,
it is
I
when
know.
oxygen.
This extra information,
it is when,
Ra.
it is when
Extra information, Ra. I'm not telling its answer.
So oxygen will just gain 2 electrons which were lost by magnesium, and it will also complete its octet. Got it?
Yes, sir.
So
Yes,
now we are
sir.
having the 2 oppositively charged
Mg will
ions.
give its
One is
2
Mg2
electrons the
positive,
transfer.
another is my oxygen 2 negative. So they are oppositively charged ions. So they will what? They will attract each other, and that
Attract each
attraction
other.
is the ionic bond.
Ionic bond.
Got it now?
Yes, sir.
Yes, sir.
So whenever you have to make any ionic or covalent bond, you had to first consider that octet or duplet it should be followed. But remember that duplet is only followed by hydrogen, helium, lithium, and
But
beryllium.
what if the valencies of the metal and non-metal are different, sir?
Valency will be
They're
different.
always different, Ra,
Sometimes
most
it
of
may
the time.
also be same. For example, lithium, its valency is 1. Hydrogen, its valency is also 1. So sometimes valency can also be same, that of metal and non-metal.
No, sir. He's asking like
Man,
Al2O3.
Yeah, when the valency, let's say Mg's valency was not 2 but 3, then what would have
That's
happened?
Al2O3. Ra.
Yeah,
No,
Al2O3
its
basically.
valency is always 2. How it can be 3? Magnesium
No,
valency
sir,
is
I'm saying what if the sir, when does an ionic
Then-
bond form? When a metal and a non-metal reacts, right? Sir, you gave us an example when there is 2 plus and 2 minus, so it will cancel and it will become
neutral.
neutral.
Yeah.
What if the
like
valencies are different?
Al2O3.
Yeah, what if the
They are
valencies are
2 or 3.
different? Like the
They're
metal
not
has
balanced.
metal has 3 metal has 3
Al2O3.
plus
Ra.
and
That's it. Ra.
hey, I'm
Okay.
asking him how
I
is
will
it
give you the example.
possible, duh? I'm not asking an example.
Okay.
No, I'm not answering
think
you.
you
I'm
should
just
shut up
putting
for
your
the whole day.
question
He's
in
asking
simple
for that.
terms. I'm putting your question in simple terms.
Okay, if I will
You
write like
say
this, that is
how is
MgCl2.
A? Yeah, yes, sir.
Okay, I will tell you. So there will be also the ionic bond here. So let us see how it is actually formed. So magnesium, I already told that it has two
282
electrons.
or 12.
Yeah,
Two
282. So
electrons.
that means it will just lose two electrons in order to complete its octet. So I will write it like this. That is, it has now 2 comma 8. So octet is complete. Now these two electrons, they will be just taken. One electron will be taken by one chlorine, and another electron will be taken by another chlorine.
Yes, 3 is for chlorine, like in the valence electron.
In the valence electron, okay, I will write chlorine. Its atomic number is 17. So it has 2 comma 8 comma 7.
3.
Right?
2, 8, 7. So 2,
Yeah.
8, 3, sir. Oh, wait. No. Oh, okay. 2, 8, 7.
Chlorine is 1
Okay,
minus.
I'll take. Yeah, okay, sorry.
So when here it is now
1 minus.
chlorine
What are you talking
1
about?
minus.
1
So that
minus means 7.
I know. I'm talking about the
it has
valence.
one. It has one less electron. That means obviously it's 7.
yeah, exactly. It has one less, so it will only gain one electron. So it will now complete its octet. So it has now 8 electrons. Now, how you will write it? You will write just like this. You are having magnesium 2 positive, and there is
2 positive.
chlorine negative. One will come just like this, another will come like this. So there will be now attraction, and that attraction is the ionic bond.
Oh. Yes, sir.
Whenever there is oppositively charged ions, so definitely there will be ionic bond, and whenever there is metal and non-metal, there will be ionic bond. You have to remember this. This is very important.
1 second, wait, sir.
Yeah, just write down this.
Done, sir.
Sir, I don't get it. Like when magnesium is like, where did that 2E minus come from, sir?
2E minus what?
2e
Yeah,
means it has just lost 2 electrons. 2e means electron. It is here the
Lost 2
electron.
electrons.
Why magnesium will lose 2 electrons? Because in order to complete this octet, in order to be stable, because any atom who follows this octet rule, that will be stable, because noble
Has to
gases
be
are
stable.
stable. Just if you can see, helium is a noble gas, it has only 2 electrons, so 2 means it has completed its duplet. And similarly, neon is a noble gas, it has 10 electrons, so that is 2 comma 8, it has completed its octet. Argon has 18 electrons, it's also a noble gas, it has also completed its octet, so that's why they are stable. So any atom wants to become stable in order to complete its octet or duplet. So they become stable after completing their octet or duplet. So that's why either atoms will lose electron, or they will gain, or they will mutually share in order to complete octet or duplet.
Yes, sir.
sir. So magnesium can also react with sulfur.
Exactly. When magnesium reacts with oxygen, it is your MgO. When it reacts with magnesium, it will be MgS, magnesium sulfide. There will be also the ionic bond. Definitely.
Yes, sir.
It'd be like MgS. That's it. They both lose.
It'll be
Sulfur
like
has
MG.
15
Magnesium will
electrons.
lose 2 electrons. Sulfur will
2.6.
lose.
Mg
Sulfur
is 2 plus and S is 2
2
minus.
minus.
Exactly.
Sulfur
Mg
will
will
gain 2
be,
electrons.
They both are of
yes,
equal
Magnesium will
power.
lose 2
magnesium will
electrons
just
and
lose
then
2 electrons, and sulfur will gain these 2
Yeah.
electrons. So it will be Mg 2
S.
plus and S2 negative.
So
Shall
they
I
will.
move to the next page?
Yes, sir.
Yes,
Yes,
sir.
sir. So it's 58.
Now see how question will be asked in the exam. It is that of actually, okay, first let me give more examples of ionic bond, then we will move towards the covalent bond. So can you tell me, will there be which bond will be there between zinc and zinc oxide?
It's iconic. I would say
Ionic bond. Iconic bond.
Not iconic,
Iconic bond.
Ionic bond.
ionic bond, exactly.
Bond will
Because
be there for the history.
it will
It's
be
opposite bond.
Zn2 positive and O2 negative, right?
Yes, sir.
Okay.
Yes, sir.
Now tell me, okay, you just remember that the bond between the metals and non-metals, that is always ionic bond. So can you just remember what metals form the ionic bond? I will write it here. Metal can be lithium, sodium, potassium, rubidium,
So
cesium,
sodium is a metal.
yeah, beryllium, magnesium,
What did you
calcium,
say?
strontium, barium, all these are metals. They will all form ionic bonds. So you have to remember these
Is it
metals.
all metals or only these metals?
These are only these which actually form the ionic bond, not all metals. All
But
metals will
why
not
is
form the ionic, because most of the metals they prefer to form the metallic bond. These are actually highly reactive. They form the ionic bond. This is very important to be noted down.
But whenever, like, even if other metals react with non-metals, they'll still form a metallic bond.
No, they will form
Other
the
than these
ionic bond.
metals.
They will also form the, for example, I have just given you the example zinc oxide. Is there any zinc? I have written here zinc. I haven't written zinc, but
I
still
understand what
form the
you're
ionic bond. Yeah. But these are most common metals which actually form usually the ionic bond. You have to remember these. Okay, now tell me the
Mostly,
non-metals which form the.
mostly.
So which non? Just halogens:
Oxygen.
fluorine, chlorine, bromine, iodine,
Iodine.
oxygen, sulfur, nitrogen,
hydrogen?
phosphorus,
I don't think.
hydrogen.
Okay.
Okay.
What did you say RB was?
RB is
Rubidium.
the rubidium.
Medium.
Hey, just everything's on the
CS.
periodic table, right?
Oh.
Yeah, they are in the periodic table. CS is the cesium.
Sir, rubidium is 37, right?
Exactly, atomic number 37. Cesium is
So only
55.
there's rubidium, there's rutherfordium, einsteinium.
Rutherfordium is
Sad,
10. Rutherfordium is 104. Einsteinium is 99.
I thought
You will.
Einstein was a
My
physicist,
name will
sir.
become a
Einstein
Yeah,
is
like
the name, yeah, of the scientist who actually discovered this. That is a synthetic element.
should discover something. They'll have like nitishanium or something.
Why are there two rhodiums, sir? 45 is also rhodium. And rubidium. Oh, okay.
Rubidium, da.
Rubidium is
Rhodium
30.
is different. Rhodium is RH.
Rhodium is
Rubidium is
RB.
RB.
That
a
is
lot of
RH.
scientists have metals named after them.
Exactly,
Hey,
because these
some more years.
are the
Pentalium.
man-made elements. They have the name of the scientist who discovered
Some more
these.
in some more days,
Sir,
we'll
is
have one
sulfur a
on this
name? Is
periodic table.
sulfur a name?
No.
Sulfur is
Yeah,
not
he's
the
your
name.
grandfather.
Oh.
Sulfur is a name, Ada. How can sulfur
Okay,
be a name of
now
something?
have you
We'll
noted
never
down
know,
these?
da.
Have you noted down these?
It would have
Yes,
sounded
sir.
normal.
Sir,
Yes,
one
sir.
second, sir. One
It would have
second.
sounded normal calling someone sulfur unless until and unless sulfur the element was discovered.
I know.
Like if my
So
name
can
suddenly becomes a
so if
substance,
I'm
Shush, shush,
just
shush.
giving the example that is the magnesium nitride. So can you tell me, is it a metallic? Is there covalent bond or
Sir,
the
that covalent bond. Covalent bond.
covalent bond.
Co
No,
sorry,
ionic bond.
sorry, ionic bond.
Ionic bond.
Ionic bond. Ionic.
Ionic bond.
There will be ionic bond, right?
Oh, sorry.
Yes,
Yes,
sir.
You have to
Sulfur
just
is a
remember that if there is
Yes,
metal and non-metal,
guy in land.io. Yes, sir.
yes.
okay, if it is Al2S,
Yes, sir.
if it is
It's an ionic
Al2S,
bond.
Ionic
exactly.
bond.
Yeah, ionic bond.
Metal, non-metal. Hey.
Okay, if it is just calcium phosphide, that is Ca3P2.
Ionic bond. Sure.
Ionic bond.
Exactly. Okay,
Ionic bond. No.
I hope that you can now differentiate that whether it is ionic compound or covalent compound, whether there will be ionic bond or covalent bond, isn't it?
So can you give one example of covalent bond? I forgot to write.
Okay,
Oh,
now
an
let's
example of
move
covalent
towards the
bond.
Fluorine
covalent.
and fluorine.
I know it.
So covalent
Hey.
bond, it
Hydrogen,
is
helium, lithium.
formed by mutual sharing of electrons.
Sir, covalent bond can be any two metals or same two metals.
Any two non-metals.
Same.
Covalent will be between
Any
any
two
two
non-metals.
non-metals.
Any two
Not
non-metals or
metals.
same two non-metals?
They can be same, they can be different. I will just give you the examples. So it is formed by mutual sharing of electrons. First, note down this. So then you will write that it is formed between B/W, it means between two non-metals,
Yes, sir.
right? They
Yes,
can be
sir.
same, they can be different. For example, I will just give you the example. For example, H2 molecule, there is covalent bond and they are the same. But if I just write the HCl, HCl has two different non-metals, but there is also the covalent bond.
Yes,
Can
sir.
you tell me how there is covalent bond between the hydrogen and chlorine?
So
Chlorine
they
has
both
how many
share mutual sharing
Both
of one
non-metals,
electron.
sir.
They have like
Okay,
mutual
both
sharing of one
The
electron.
next class
Two,
will
eight,
start at
7. So it'll be one
Yes,
negative. Hydrogen will be also.
Excuse me, sir.
see, chlorine has
Sir,
7
am I
valence.
audible?
Yeah, you are
Later,
audible.
later.
Sir, the next class has started, sir.
Has time already gone?
Yes, sir.
Okay, then you can, okay, just note down this and then we will finish this class.
Yes, sir.
Yes, sir.
Chlorine has 7 valence electrons, so it has just shared 1 electron with the hydrogen. So chlorine has completed its octet and hydrogen has completed its duplet.
Duplet.
Exactly.
Yes, sir.
It's an octaduplet.
Yeah,
Yes,
that
sir.
means I
Yes, sir,
already
I'm
told
done.
that hydrogen it will complete its duplet and chlorine it will just complete its octet, right?
Yes, sir.
Yes, sir.
Okay,
Yes,
then
sir.
I hope that you will revise each and
Yes, sir.
everything from this. Have a nice day ahead.
Thank you, sir. Bye,
Thank you, sir.
sir.
Bye, sir.
Most welcome. Bye.
Thank you, sir. Bye, sir.